session. Could I get one of our committee members, Eilish or Maleva, to validate that we can be heard?
Yes, everything is fine. Heard and
Alright.
seen.
Thank you very much. Again, welcome to the second day of our open session. We're here in Oklahoma City. We're trying to gather information from states and regulatory bodies on a number of topics pertaining to our study. A little change to the agenda today. We are going to kick off with Arsalan Ansari from Darcy Partners, who's going to provide us an overview of technologies for reliable well plugging. That's going to initiate a conversation around applications of technologies and their implementation. And then after that, we'll continue with a little bit with some open session and then adjourn around midday. I'm now going to turn this over to our chair, who's going to facilitate this morning, Missy Feely. Missy.
Good morning, everyone. Thank you very much for your participation yesterday. We really appreciate it. It was a lively conversation, and hopefully we'll continue that lively conversation. It was very helpful for us as a committee to be able to have an open dialogue. We'd like to continue that dialogue. Yesterday, we talked about well plugging and monitoring, and today we're going to focus more on technologies, as Cameron mentioned. So please feel free to ask questions, and we hope to have some, as I said, lively discussion for the rest of the morning. At this point, unless Jim, you want to?
I don't, nothing, no opening from me. We're ready to go.
All right. So,
Missy, for those in the audience, attendees, if you would like to participate, you can use the QA function or the chat function. We also, if you would like to say something or participate, you can raise your hand. It should be in the reactions menu choices, and if you raise your hand, then one of our moderators can see that and elevate you to a position where you could unmute and say something. So if you do, all three of those options are available, so please use them. Thank you.
Thank you, Cameron, for that clarification. So at this point, I'm going to turn it over to Arsalan Ansari, who's with Darcy Partners, and he's going to give us an overview of the technology, which we hope will spur some good questions and dialogue through the morning. So turn it over to you.
Thank you, Missy. Share my screen. Confirm if you're able.
Yes, got it.
Again, hello everyone, and thank you for having me here. First of all, I would like to mention that it's been a phenomenal session with insights from the state regulators as well as some of the industry specialists, and getting insights on some of the orphan wells. So I've enjoyed the last couple of days. It's been a phenomenal session. So just as a means of introduction, I'm Arsalan Ansari, drilling lead at Darcy Partners. And again, I'm glad to be connected with you all. And if we haven't met, we'll disconnect after the session. So today, I'll take a few minutes to walk you through some of the latest advancements in plug and abandonment technologies, specifically those tackling surface casing well flow challenges and evolving regulatory requirements in regions around the world. So before diving into the main content, I want to spend a minute going through an overview of what Darcy Partner does. So Darcy Partners is essentially a market intelligence and technology scouting firm focused on the energy sector. We research, identify, and validate technology solutions and best practices through rigorous due diligence, leveraging both primary research and a strong peer network of over 100 partner companies. That includes 70 plus oil and gas and 30 plus in utilities and power generation. From majors like Exxon, Chevron, and Shell to independents like Murphy and Coterra, and investors like JP Morgan and BCG Consult. We support operators globally from the US to the Middle East, Latin America, Australia, and beyond. Our goal is to deeply understand the technical challenges our members face and connect them with solutions that matters. So we do this through curated technology forums. Sometimes it's virtual and sometimes in person, depending on the geographical locations. Operator roundtables, peer connectivity and collaboration on industry challenges, and almost a decade of research across 4 key channels or research coverage areas, each with several specialized sub-channels, as shown in this slide. So with tighter regulations and rising CCS activity, maintaining well integrity and plug and abandonment is increasingly challenging. Despite advances in cementing, issues like surface casing, vent flow, and gas migration persist. Next generation PNA materials are essential for reliable, long-term gas-tight isolation and more efficient abandonment operation. So let's have a look at some of the key trends for orphan wells with surface casing vent flow issues in US and Canada. While documented wells in regulatory reports number around 180,000, estimates suggest true figures could be as high as 800,000 for some of the unreported wells. Canada, Ohio, and Pennsylvania lead in casing vent flow issues due to stringent regulations and active drilling. Oklahoma, Kentucky, and New York show moderate cases, while Alaska, Alabama, and Michigan report fewer cases due to limited drilling and operators complying with the relaxed policies by the regulators. Over the years, well counts for casing vent flow issues have steadily grown as well, with the US historically outpacing Canada prior to 2010. However, since 2017, the US has seen a decline in orphan wells with casing vent flow issues, while Canada's numbers continues to rise, pointing to operational and regulatory differences. Moving forward, addressing these challenges through policy improvements, technology advancements, and industry collaboration will be key to mitigating long-term casing vent flow risks. Also, it's estimated that 66% of more than 900,000 onshore oil and gas wells are marginally productive or nearing the end of their life. These idle or permanently inactive marginal wells face a high risk of improper plugging and abandonment, increasing the potential for orphan wells. Now let's explore some of the operators' perspective on plug and abandonment challenges. In a recent Darcy Forum poll, regulatory approval and compliance emerged as the biggest hurdle, even with growing CCUS activity. Operators are shifting towards cost-effective, rigless PNA methods. About 37 to 42% of operators aim for rigless decommissioning using lightweight vessels, resin-based plugs, and remote monitoring. However, concerns remain around the long-term reliability of these lower-cost solutions. Meanwhile, 32% of operators focus on plug durability and 26% on well integrity or CO2 storage. This shows that PNA is critical for future energy applications like CCUS and geothermal, driving demand for next-gen sealing materials, expandable plugs, and AI-driven monitoring. On the right-hand side, we look at the CCUS activity trends, and we can see adoption is accelerating with near doubling of advanced stage facilities with a 60% rise in construction activity. But infrastructure bottlenecks, supply chain constraints, and policy gaps create regional disparities. Moving forward, PNA is no longer just about abandonment. It's about ensuring long-term well integrity for energy transition. Advancing policies, technology, and collaboration will be key to tackling these challenges, especially to align regulatory frameworks with rapid CCUS growth. Now let's switch gears to evaluate global regulatory challenges in plug and abandonment. Non-routine operations where alternatives to cement are used require deviation requests, extensive documentation, and strict verification, leading to delays, adding regulatory burden to operators. While US regulators allow variances for novel decommissioning methods, long-term well integrity remains the top priority. Overall, in a nutshell, regulators are beginning to accept alternative materials for permanent well stability globally, and advances in resins, polymers, expandable plugs, and bismuth could lower costs, but has slow adoption rate with limited field trials. Next, we'll take a moment to review the key challenges operators face with plug and abandonment materials, as current solutions often fall short to address the problem effectively. A permanent well barrier must provide a tight seal, precise placement, and long-term stability against mechanical, thermal, and chemical stresses. Firstly, plug-in materials should have very low permeability, almost less than 10 microdarcy, and must bond effectively with casing cement and the rock formation to prevent leaks. Interestingly, field trials show that smaller incremental applications can become better than large slugs, but this conflicts with sometimes with the operator's preference for faster P&A operations and cost cutting. Secondly, barriers must be placed in front of impermeable cap rock and overlap existing cement. Again, the challenge is detecting the precise leak paths, which is difficult since traditional logs can't identify tiny microannuli. Regulators emphasize sealing external paths, so placing barriers outside the casing is critical, but yet challenging. Finally, barriers must resist degradation from pressure cycles, temperature changes, mechanical stress, and chemical exposure. Ultimately, ensuring long-term integrity requires precise placement, thorough testing, and confidence, ideally with reliable monitoring or self-healing materials, as current solutions don't guarantee permanent sealing. Now let's switch gears to explore the evolution of P&A materials ranked from left to right based on long-term integrity and cost. Starting with cement, the most widely used material, but prone to shrinkage, cracking, and gas migration. Innovations like microfine self-healing and expandable cements aim to improve its sealing performance, along with thermal cement specified for oil sands. Innovators in this space include Astomer, Expro, Trican, Schlumberger, and Baker. It's important to clarify that cement remains a fundamental component of well abandonment and integrity management. And the technologies discussed here are not replacements for cement, but rather complementary solutions that address specific challenges such as sustained casing integrity, gas migration, and healing requirements, where enhanced sealing is required, not as a full-scale replacement for cement. Next on the list, we have non-settling grouts in bentonite that offer sealing, self-sealing properties and are well suited for temporary abandonment, but they can swell excessively and shrink in dry conditions. Companies like Bentera and Flow Petrol are advancing these solutions with moisturized and self-healing bentonite blends. Thirdly, we have resins or polymer-based plugs. These provide particle-free, high-strength sealing, but come with challenges like high cost, difficult removal due to strong bonding, and the need for precise curing conditions. Companies like Experwell and Welsim lead in this space with thermosetting polymers. Fourthly, we have the elastomer-based expandable plugs that includes expandable liners and rubber-like polymeric plugs, offering flexible sealing but have possibility of degrading under extreme pressures. Advanced formulations like thermoplastic elastomers and advanced rubber compounds are improving longevity with innovators like Weltec, Pinnacle, and Winterhawk. Lastly, we have the thermite and bismuth-based alloys that create metal-to-metal bonds for permanent sealing, leveraging bismuth's low melting points, high density, and expansion properties in sustained casing pressure scenarios. However, they do not replace the fundamental role of cement in well abandonment. While promising, these solutions face challenges with scalability and reaction control. Notable innovators in this space include Interval, BISN, Isolate, and Wellstone. The landscape of P&A materials continues to evolve with the goal of reinforcing cement's performance rather than eliminating its necessity. Taking a step further, we compared innovators in this space, focusing on the technology benefits and considerations for each of the bismuth-based plugs. Interval stands out as the only provider using thermite to create a permanent gas-tight barrier by melting casing and cement with the thermite reaction. Benefits include open-hole sealing without section milling and high barrier placement confidence. However, there are high temperature considerations and one-shot limitations for re-entry of these wells. But it has been proven in field trials across Canada as deployed by Shell, Cenovus Energy, BP, and Total. Other providers like BISN use heated bismuth alloys that sets as it cools with seamless sealing, but these require section milling. BISN plugs are versatile with applications beyond P&A like workovers and have been used by major operators worldwide, including Total, ConocoPhillips, and ADNOC. Thirdly, we have Isolate that uses bismuth-based alloys with high shear bond strength to steel, ensuring zero emissions. They have successfully been deployed in 9 trials with Total, Nobian Energy, and others, but selecting the right alloy is crucial for effectiveness. Lastly, we have Wellstone's technology that's currently in trials with Total Energies in North Sea. but it offers precise depth control using a downhole electric heater to melt bismuth alloy. However, plug depth is limited by voltage capacity in deep wells beyond 4,000 meters, and careful temperature control is essential. Now, moving on in the sustainability space, innovators are also imagining end-of-life wells, not just for abandonment, as shown in the gray section, but for repurposing into energy storage in yellow, geothermal in orange, and carbon credits in green. One of the innovators to highlight under the BNA is the biosqueeze that uses a biomineralization process developed with the US Department of Energy, where bacteria creates a calcium carbonate to seal leaks with a permanent gas-type barrier. Thermal energy storage stores surplus energy generated through renewable sources such as solar and wind in the form of heat, preventing its wastage by injecting hot fluid into underground reservoirs. Innovators like Renewable have been expanding in this field. Thirdly, we have the geothermal energy that takes advantage of existing subsurface fractures. Oil and gas wells are reused to re-inject water and brine that will be heated by convection on the surface. These fluids will be produced in a second well where heat will be harvested as electricity via ORCs generally. Again, this can produce from 75 kilowatts to a couple of megawatts, depending on the subsurface. An ideal solution if there is a need of power on site, but would still need to make economics work. We also have the advanced geothermal systems where oil and gas wells are repurposed to create a closed loop, usually in the form of insulated tube, as shown in the schematic below. This is then used to produce geothermal energy as the hot fluid will flow back through the insulated pipe to generate power. Lastly, we have the early abandonment, which is keeping to the ground credits. These innovators identify early retirement opportunities for wells based on the emissions calculated, determining the well abandonment cost and estimating the price of carbon credits. Their role involves finding buyers for carbon credits, connecting them with the well operator and covering the expenses of well abandonment. These solutions show how P&A is shifting from a closer activity to an opportunity in the energy transition. So to wrap up, I would share this is one of the Darcy event that was conducted a couple of months ago. And if you're more than welcome to join the link here, and for a trial session, you can view the event. But just to wrap up, orphan wells with sustained casing vent flow are exposing the gap between regulatory processes and available technology. And as CCUS and rigorous P&A solutions advance, outdated abandonment policies and infrastructure gaps hinder scaling long-term well integrity. Trials of intervals rock solid have shown that it can seal vent flows where cement squeezes have failed, creating a permanent, verifiable barrier without compromising pathways, as tried a couple of times with Synovus Energy. We also have the BI-Sense bismuth-based alloys that are also proving effective across P&A workovers and integrity restoration. So proper casing preparation and thermal expansion are key. As P&A evolves, hybrid strategies, which is including cement plus advanced materials, are becoming the new standard. So proven technologies exist, but unlocking their full potential requires policy frameworks to evolve just as quickly. Again, I thank you all for attending, and we'll be glad to have any further discussion or answer any questions.
Thank you very much, Arsen. Very interesting. So at this point, I think we're gonna open it up for questions. And if you have a question, please use the raised hand function or the Q&A function in the webinar. So are there any questions at this point?
I have a question. You mentioned a technology that melts the casing, the cement, and the rock. What technology is that? There's been similar discussions around in Pennsylvania. I don't think, to my knowledge, we use that. Are there any places where that's been used?
It has been heavily deployed in Canada, about 50 to 55 wells, and with multiple operators. With US, it's still under trials with some operators, but haven't been tried extensively in US. It's more trial because of the CCUS projects in Canada and to utilize some of these wells as future CO2 storage.
And that's been deployed mostly to address like annular pressure
So any of the surface casing, vent flow issues, the high annular gas migration pressure, so it has proven to provide 100% leaks there. But the only challenge, it comes out to be sometimes operators are more concerned in getting a second leak value that comes below the remediated interval. So that's where they are concerned about re-drilling these termite plugs and not being able to re-enter back into the same hole. So that's the biggest consideration that the operators and regulators put while deploying some of these plugs.
In the cases, the 50 to 55 that it's been successful, like what's some of the pressures they were dealing with? Is there any limitations of?
So they have had, no, they have, so they were, it's not limited by pressures and either by temperatures. So they have seen like pressures go up to like 2000 PSI and they have kind of dealt with that. And when it comes to like deploying this, so like for re-entry of these technologies, so Cenovus Energy has tried and drilled back one of their plugs successfully and covered it with the liner. So that has been successfully tried.
Thank you.
Adam?
Thank you. A great presentation. I wonder what can you share on costs, either like actual costs, if you can share those, or relative costs if you can.
So with Darcy Partner, we provide a more of like, you know, the innovator comparison we have here. So a cost comparison between the technologies, which will be a multiple of like 1x or 2x, how each of these technologies compare to each other. But the actual cost is when the vendors are connected with the operators or someone who wants to deploy the technology. So normally we don't have the cost component being shared at Darcy.
Can you speak at least relatively speaking, which of these costs more and which of these cost less?
Oh, yeah, definitely. So the interval and BISN, we have been the almost 2x the price of what we have for the other ones, but yeah, relatively it depends on the application, it depends on how many plugs have to be deployed because it's a cost per plug. So yeah, it again depends on that. It depends on the conditions as well.
Can you speak at all to what percentage of a plug job cost is these technologies and what is other things like labor?
So they come as a package, like when we have our interview conversations with them, they come as a full package with regards to the labor, the rental equipment and the material cost. And it's a lump sum cost that's offered. So it's not like a cost per barrel, a cost per like footage. But yeah, it's a lump sum cost per plug. And then they also have like kind of depending on how many plugs are required in a well. So as we mentioned that this technology cannot replace SIM, it's used only for a specific application just to seal off any casing vent flow issues or casing migration issues. So it's not a kind of like you can use it for the entire well.
Thank you.
There's a question online from Matthew Terry. What regulatory firms need to be made to allow new technology to be applied? Where are the bottlenecks?
Sorry, once again.
What regulatory reforms need to be made to allow new technology to be applied? And where are the bottlenecks?
Now, I believe like this is like the bottlenecks, as we were having this discussion that having the operators regulator discussion and getting the technology innovators being involved through the operators is the bottleneck. Getting them on the same page and having to deploy this based on the cost components. So yeah, I believe that's more, it's again a great question, but it's a space that we're still evolving into. And as more and more discussions take place, some of the amendments and manuals and modifications can be added to the regulators for new technologies to be considered how the risk assessment or risk-based assessment can be carried out for these technologies.
Any comment from any of the state? Yes, sir.
I'm sorry, just a quick logistical note. If you could please introduce yourself for the folks online before you speak, that'd be great.
Sure, Adam Wygant from Michigan Geologic Resources Management Division. Most state oil and gas regulations, Michigan do allow for other plugging materials to be approved by the supervisor. So we have the ability to go through this process and improve it. You know, we're not anywhere near like advocating or changing this, but I think processes do exist for this evaluation, but what was kind of mentioned yesterday is that whole process of assuring us that, you know, this isn't a scam, it's, you know, it's gonna hold up for the long run. It is indeed a good material and an improvement, so to the extent that it comes well documented, tested, somehow approved by API, NATL, something, I think is helpful to state regulators.
100%, yeah, and verifying this technology, I believe like it's 100% great comment here that we need to verify this before getting this into the field.
I think I'm sorry, Catherine Dickert, New York State Department of Environmental Conservation. And I don't know if Paul's on, but he could speak to this more, but we have had operators use both BioSqueeze and BISN in wells. I don't think the results were quite what we were hoping for. I don't know if Paul can add to that.
Sure. We let people pretty much try things that are, you know, that have been used in other states successfully. Like Catherine just said, they don't always work. The bottom line is the well has to be plugged. And if they try a technique that doesn't work, well, they have to try something else. So we're pretty flexible about what procedures and operations we allow them to attempt. And I could definitely see them, you know, us allowing this process to go. So
100% agree, Paul and Catherine. So yeah, just a quick, maybe very quick comment here is that with the deployment with Synovus Energy for Interwell, we have seen that their first trial didn't go well, although they had carried out all the considerations, all the operational parameters that need to be done. But then they found out there was a second microannuli channel that was not detected by the cement. And that's a kind of challenge we still have with the traditional cement bond logs technology. They're not able to detect the microannuli that are less than 100 microns. So yeah, as we kind of like evolve and develop more of the logging technologies in this space, we can get to know the well better behind the casing and get to plug it in the right intervals.
So does that mean, or this is Catherine again, does that mean if they do the melting of that in the wrong place, and I think you had a note on there that you get one chance.
Exactly.
So then if they're above where they're supposed to be, like that's their one chance, what did they do then?
So yeah, I mean, they can do multiple plugs. So like, let's say they can verify the source of the leak or the leak path itself, whether it's shallow or it's deeper. And again, the plug, both, like all these technologies are available. So they mentioned it as a one-shot limitations, but they have done a trial where they have drilled it back. But still, you know, unless we have more and more of these trials and get more confidence, yeah, I believe getting this technology viable is still a challenge.
Any other comments from state representatives?
Yeah, this is Joe Gaboff, plugging chief from Pennsylvania. We have a process in our state where we can introduce new technologies, and it's an alternate method form. And basically what it is the contractor, the operator, they submit this form, and they basically have to demonstrate that this method meets or exceeds our existing regulations. And, you know, that form's been done with BioSqueeze. I know BioSqueeze has been very successful in Pennsylvania. You know, and part of that alternate method form is we might approve it under certain conditions. So like BioSqueeze, for example, we required them to run a CBL before the job. You know, pinpointed where we wanted that interval squeeze, both in terms of geology and where it'd be most effective. That technology seemed to be most effective where you had pretty adequate cement bonding already. And in the jobs that I saw BioSqueeze work on, they didn't really put a whole lot away, quarter barrel. And over time, you saw that surface casing pressure start to drop off. But yeah, something like this, I mean, I'm thinking like, you know, someone were to do that alternate method form, there might be certain conditions for this, like set the plug, maybe a follow-up, see if they're, you know, shut down, it's monitored, see if it's coming from a different interval, and then address it as needed.
100%, like long-term monitoring is critical right now, as we discussed yesterday as well. For most of these wells, even after plugging them with most of these technologies, still the monitoring is key here, because these wells, we need to make sure that they are plugged for like 100 and 200 years, and they haven't getting these issues back in the well. But again, like also the industry is going towards self-healing materials that are having these self-healing capabilities, whether it comes to cement or some of the other like resin-based plugs that can self-heal based on like pressure and temperature degradations and not come under those considerations. Great point, Joe.
Any other comments? Paul?
Yes, I didn't introduce myself as Paul Giacchetti, Regional Oil and Gas Supervisor up here in New York State. Arsalan, I have a question. The testing that they've done with this, did they ever try to maybe drill out the plug once it was installed, or is it just, with the melting of the casing in the one example, it's just something that would be way too difficult?
So with their with their first trial, as mentioning to Catherine, that we had, they had an issue with their plug not able to seal and finding a deeper leak point. The macroanalyte had second leak path. They had drilled it with the conventional bit and or was it a bit or a concave mill? So they were able to drill it out, and she got back access to the entire wellbore, and they went deeper and did a second plug that was able to leak off the vent flow path or the gas migration that was coming to surface.
Okay, thank you.
We have a question from the online audience from Zach from DOE. Is that somebody we can plug in here? Here he is. Zach, can you go ahead? You're muted if you're attempting to speak.
Can you guys hear me?
Yes, we can hear you, Zach. Thank
Okay,
you.
great. Sorry about that.
It's okay.
When you say long-term, what exactly does that mean? Because the website that it is that I'm out here, we have to model and calibrate our PA to 10,000 years. And so with borehole permeability going anywhere about 200 years, especially in the area that we're out here in Carlsbad, which is a huge oil and gas boom. It's a concern of ours because with all the oil and gas going around our land withdrawal site, along with our existing wells that we have a fear that we're eventually going to wind up with one water table. So with these additional and new materials and methods, does it extend the lifespan of borehole permeability?
Great question there, Zach. So 100% I agree that, when it comes to long-term, we don't have a timeline that's, a guarantee that's offered because of a lot of like different challenges. Firstly, we have like nearby, like let's say for some of these wells in Canada, there's a lot of nearby seismic activity that's going on that kind of operators are faced with some challenges because of this getting impacted on their orphan wells. But then when it comes to like defining the exact timeline, like we have had discussions with the operators. There's not a defined timeline that they have mentioned or modeled that. But then they have like for example, with Interwell, they have this continuous monitoring technology that's installed after the well is abandoned. That's a part of their package that does the monitoring and barrier verification for like the number of years that the operators are looking for.
Will it last 10,000?
I'm definitely not sure about that, but yeah, then
Would it last more than 200?
It's, yeah, I mean, the attempt is to do like a permanent solution, but again, it's impacted by various factors. So still, like I would say this space is still evolving. We are not like 100% there. But yeah, with the monitoring and some of these involvement and innovations by the innovators, we can get to like reach a certain number there.
Do you have any borehole laboratory testing on this that would be comparable to normal plugging methods?
Definitely, yes.
Any publications, anything like that?
Oh, yeah, I'll be able to check that because we normally have that in our database, but I can definitely share that with the team here at National Academies, and they should be able to share that link with you.
Okay, thank you.
Thank you, Zach.
Any other questions? Mileva, you've had your hand up and down through the morning. You have a question?
Yeah, I thought we should give priority first to non-committee member audience. Yes, few things. Well, thank you very much, Mr. Ansari, for a very comprehensive overview of some of these materials and technologies. Just to clarify, your company is actually not involved in any research or testing or application of these materials, correct?
100%. Yeah, we are just doing a researching and overview of these technologies. We are not involved in the trials. We are getting to know from the operators.
Okay, so like just, you know, on something, most of these have been actually shared at the SP PNA forum in 2019. And these technologies have been thought about or tested in some places, probably for the last 10 years. So one on the heating the metal to metal, you might form a bond and seal there, but that heat creates potentially issues for any water-rich materials such as clays and any other cement that might be there that do not do very well where superheated. So I think I agree with Zach. Before we start, giving seals of approval on these, probably some documented research is needed. And I think it's a great compilation. It's good to see that these things are being kind of initiated. As I said, some of them have been already in a kind of process for a while. But I think before you can start answering some of these long-term questions, the API standards on testing cements, a good example of how much testing is needed before we can with certainty say that something can last, 50 years or 100 years, like in case of cement. So it was more of a kind of a comment than a specific question. Thank you.
100%, I agree with you, Mileva. Like the high temperature concentrations are there for any nearby adjacent wells that they have, because the temperatures go up to like 3,700 degrees Celsius. And then, yeah, lab testing again, as per the API standards have been carried out. So again, we'll try to share that research at a later time with the team here.
Any questions out there from members of the committee?
Yeah.
Someone in chat.
Oh,
Is there somebody in the chat?
The last one from Matthew Terry.
Yeah, I guess, okay, so here's a question from Matthew Terry again. Thank you, Matthew. Approximately how many wells have been plugged to date using these new plug materials and methods? How long have they been in place?
So, great question. I can share a very quick overview of wells. Don't interval, please.
While he's looking that up, I would just like to comment, go ahead, while you're still looking that up. This is Jim from Michigan, manager of the Orphaned Well program. I just want to make sure that we all understood, because it was only briefly mentioned, you know, these are materials and all these methods are not replacing plugs. These are being used to augment cement plugs.
No, that's a really good point.
That is a
Yeah.
very excellent.
That's
I
a
don't
great
think of
point.
them as this is going to be the new plugging material.
Right.
They're just options to assist in augmenting cement plugs.
100%, yeah, it's not a complete like replacement solution, just one consideration for like one problem or tackling one challenge at a time. But Matt, here we have like some of the records for the interval wells that's been carried out in Canada with the different setting depths and like with the number of years. So this technology was like introduced back or started trials in 2020. So it's been there for 5 years now, with some of these partners or industry operators who are being deployed in their wells. For we get a deeper dive of the other solutions as well, for how many wells have been tried.
Could I just ask, is this, how this is in place? Is it wireline pump? How is the plug generally set?
Oh, so it can be done by, like, it's mostly done by E-line, but can be done on drill pipe as well.
David?
Yeah, so a question comes to mind when I look at the run record, and you had mentioned something about Interwell has a monitoring package. Is that associated with this, and can you speak more to that on what does that entail?
So basically, once they have the plug in place, they have a post data acquisition package where they have these barrier verification systems that are run based on some of the noise logs, cased hole analysis tools, and some of the pressure and flow data. It's a combination of different methods for data acquisition that they have been carrying out, and just kind of ensures that this well has been integral and continues to be integral for the remaining years.
Okay, so it doesn't stay in the well. This is something that they do periodically, so they don't cut and cap or bury it. Okay, all right. So it's not really a passive or.
No.
Okay.
Just out of curiosity, how long do they monitor for?
So like right now, they've been like, let's say the oldest well has been monitored for like 5 years, but again, it depends on the contract or how like the services are still being utilized. So it depends on that.
Yeah. And I'll clarify too, you know, I think I'll echo Maleva's comments, is it is a comprehensive overview of what's out there. And that's kind of the task, is looking at current and emerging, not to say that this is the answer, but what is there? What can we do to maybe continue to advance it in the future, right?
Correct, exactly. 100%.
I have one more question for you that I thought of. So traditional squeeze work, we set our purse, we'll set a couple barrels behind pipe. It's almost like a race against time, you know, the cement's got to set up before it starts channeling. A lot of times we'll see backflow or backside pressure shut off immediately. Over time, it'll rock up as it starts channeling
100%.
through. Is there a set time, you know, once this gets deployed, is there?
No, so once it's deployed, it's like from the time it's deployed which is few hours, maybe 6 to 8 hours. It's 100% sealed from that time. It doesn't take like setting time for cement like 24 hours or 48 hours, or you know. But then again, monitoring that like the first 6 months or like a year is critical again, as for most of the other plugs. And yeah.
Jeff?
You're kind of like monitor the scope of the industry type of service, right? So I was wondering, do you have a comprehensive look at all the different, from Portland to, I call it enhanced Portland, which is some of your self-healing, your expansion, cements, to these technologies, to biosqueeze, to nanotechnologies? Do you have a scope of what percentage and what does that look like? Let's say in the US for an example?
Yeah, no, we kind of like know the innovators in that space, but again, we have got selected innovators like biosqueeze, Interwell, BISN, XPro. So we have kind of like researched some of these like various innovators, but again, it's a great topic of research to kind of like get the percentage deployments of seeing some of these technologies here in US and Canada. So we definitely can look into it and maybe do a deeper.
Canada has some government initiatives evaluating plugging materials, squeeze materials to fix Portland and PNAs and things that
Totally.
it's very comprehensive. It's bringing that in. I'm just looking for a conjugator. Data aggregator would be nice, so we don't have to do it ourselves, but
Sure, definitely, we can put this material together as part of our.
it's nice that there's a look at, okay, the bismuth plug, you know, thermite, yes, get that bio squeeze, okay, the bio microbiology path. There's some other technologies I haven't seen you touch, but
100%.
a place that is aggregated outside of a service company, whatever service company is gonna obviously push their sales opportunity, right? But something that says on the market, this is what's out there, this is where it's being utilized, and this is it's in comparison to Portland around.
Yeah, so yeah, again, you're right, we just kind of like research just the innovators who have been deploying this technology in that space, but getting the actual like trials or actual results of these technologies, yeah, maybe you can do a deeper dive into it.
Yeah, there's quite a bit around, you know, polymers, resins, hybrids with resin and cement, there's all kind of different things out there, right?
Totally.
So just
Good to have that.
a comment off is kind of where do we draw the line for this scope? Because that's, you know, the technologies chapter, we talk about, you know, there's so much out there. This just scratches the surface, but, you know, obviously we want to high grade, what are the most, you know, big hitters? So maybe it's more for like the committee and the subcommittees to kind of.
I'm not sure if that's the committee's job, but the
Yeah.
industry's job.
Okay.
I don't know if any committee member would want to take that on their shoulders.
No, what I'm saying is, what do you put in the report, you know, as far as?
I don't
all-
think that
yeah.
that's also our thing. I think our thing is to open pathways of innovation
Mhm.
and let the industry innovate. What's successful, what works, what's economical, what is fit for purpose, not, you know, I don't think that's hard for us as committee members to understand that nuance. I think these guys have done a good job of explaining some of that nuance yesterday.
I'll say, what I think the committee does have, I'll kind of weigh in on that a little bit, a role to help identify, and this ties in with things like our conversation yesterday on avenues of failure. The committee, I think, could identify areas where advancing technology would be productive.
Yes, and like we're seeing leak paths of this kind.
Yeah, or we're seeing, you know, we've been, you know, using these, you know, and that goes back into doing some of the basic analysis of, you know, if our plugging is largely successful, well, where are some areas?
Yeah,
where it would
identifying
be-
the problems and challenges. to
What are the problems and challenges? Because that points you where, not to specific solutions, but
Exactly.
where, you know, research might be needed, research verification, and then it gets into, and you know, and Missy and I are we're gonna pivot here in a second, but it goes into this, but I won't yet.
It's, you know, I'm a relatively young man. I've been in the industry 20 years, but in that 20 years, I've been proven wrong more than I've been proven right on what I think the next thing is going to be, and that's actually my job is to predict it. So it's really weird to I think the biggest thing we do is kind of like a child, right? Wondering what a child's gonna be good at, now just give them the tools to be good. And allowing innovation and saying, we see these failure mechanisms, or we have a data aggregator such as yourself that says this is how the market looks.
Yeah.
From a holistic perspective. So a regulator could sit there and go, well, that's what's out there. This is kind of where it's being used in comparison. If something's getting used a lot, by and large, we're pretty good about not overspending our money. It probably means that it's a solution that is being helpful, but in the early stages, there needs to be an incubator to allow for technologies to come, because you guys have said multiple times, we're scared to be the first. Or it might be great, but I don't want to be the one to find out. I want somebody else to kind of have proved that out. And an incubator is a committee member allowing a pathway for third-party verification, unbiased verification, because I think that's come that I've read in between some of the comments is that unbiased opinion on. It's like, is this a scam? Like, is somebody trying to say, am I getting a used car salesman and this a lemon that barely runs, or is that's kind of, it's what you said this morning, right? And so I think services like yourselves that is holistic, not tied to 3 or 4 technologies, but the whole space, I think is.
100%. No, I agree. That and the process that we follow here at RC as well is verified with the operators who have actually deployed it to know where the actual trials have taken place, which fields they've been actually deployed, and how their results were. And they can also speak out of their, like, without the innovators being involved there. So with just having the operator and RC conversation.
It's valuable. I said, okay, I'm trying to say, like, I think what you're doing is valuable. I would want more. I would want it to be broader.
But definitely we can enhance this report, like this framework, to like see the number of trials being carried out with each of these innovators. We can look into that.
You talked about forecasting. Our job is not to pick, just forecast the car, but maybe to forecast that once the car's there, where the traffic jams are. My concern is that we are not doing enough to sort of encourage innovation in the space. One of the reasons we've got such great cements in the oil field business is because people are willing to take risks and try a variety of things. I mean, oil field cements have advanced far faster than building construction has, and because of people have these very conservative approaches, and that's where we are in the regulatory space, and I don't know how to balance that need to encourage innovation and testing alternatives with the inherent conservative, it's like my old manager who wanted proven new ideas. And so I think there ought to be some space, some mechanism to accelerate testing and encourage some innovation without necessarily onerous penalties. And I don't know the format for that. Maleva and I would love to have that be university research, I'm sure, but we'll see. If you've got good ideas in that space, I would sure want to encourage them.
I have a question from Dwayne. You want to verbalize it?
Yes, thank you, Missy. Arsalan, thank you for the presentation. I appreciate the comprehensive overview. There's one other technology I have heard of that you didn't discuss. Do you have any insider information about it? The idea was to inject a scale forming liquid or some other sort of blocking fluid directly into the formations that would otherwise flow. So rather than just plug the pathway, the borehole, you plug also the formation directly itself. Are you familiar with that? Any insider information?
So is it similar to like having a polymer type fluid that's injected into the formation?
Yes, it's there are a couple variations. One uses the same sort of water control technologies that we've used in the past, and the other intentionally creates a scale. It's sort of the opposite of the chemistry of dissolving scales, precipitate a scale.
Oh no.
Yeah.
Sorry, no, I wasn't aware of the technology, but I know like some of these plugs, or like the polymer based plugs, like Biospace, they have been tried injecting into the perforations as well. And but then I don't know about the scaling technology. Maybe I might have to do a deeper dive.
How did it work with the BioSqueeze and the others, the polymers injecting into the formation?
So they had initially some back pressures that was experienced because of that formation pressure, but then they were able to like apply or increase the amount of pressure that's applied from surface. And but I'm not sure like which areas or which region or which basin was it tried at, but we can get more insights into that.
Thank you.
I actually have a little insight onto one of the scale formation with injections, and they had some great results plugging up things that were like great big holes, perforations and so forth, but didn't get scale propagation through small cracks. That was just that example. So I don't, and so it probably wouldn't plug microannuli as effectively as it would plug perforations. That was just that example.
Maleva?
Yeah, the question was there how we would test this and, you know, how we can move forward. In talking to various people, you know, from industry and academia and national labs, you know, you do sometimes get a really good idea, good technology, it has good scientific and engineering base, but it really fails because of bad business plan, not because it's a bad solution. And then equally, you have some really bad solutions that just have good business plan and they proceed, you know, not just in P&A and materials, but in every aspects of human activities. So that's general comment. The more specific comment on, are we doing this kind of testing? I do know that we actually are doing. And if you look at the national labs, you know, from NETL all the way across to the West Coast, you know, we have several labs that have amazing capabilities in both robust modeling and testing of these materials. One particular study, for example, that comes to mind is after BP Horizon, NETL teamed up together with several operating and service companies, and they really did a comprehensive testing on foam cement, etc. So we do know how to do it. We have means of doing it. I think, you know, at some point, it's just the motivation to do it and funding. Thanks.
Thank you, Maleva. Any other comments? You wanna, Tim, you wanna introduce our little pivot here?
And I think this pivots off of a number of the comments, because what hasn't been mentioned, well, it has from the regulators a bit, but is there a methodical process to move from technology? I mean, there's all the marketing side and all that, but to move actually to being approved through the regulatory system. And I've had some occasion working on that at the federal government and some studies, and I'll just share a couple bits of information because, and then I'll get into my opening for the discussion. But for instance, on methane monitoring, DOI, EPA, the Pipeline Hazardous Materials Administration, all have different criteria for implementing new technology. There's no way of standardizing technology across these different agencies, which creates a real inhibitor. And I'm hearing kind of the same thing would be, and granted, recognizing that states have different geology, different environments, so that could impact it. But wouldn't it be nice to have a system where you could move across, and I think there are some mechanism out there. Somebody mentioned that states, and I remember states I worked in regulation, we referred to API standards, and I'm gonna, just a quick heads up, and I know we have somebody from API on the line, but just in fairness, API has a lot of different groups, and they have a whole standards group, and then they have groups that work on policy and other things. But if our API colleague that's on wants to talk about anything on the standards process, or I think that's on our list for our information gathering, to bring somebody in from the API standards organization to talk about that process. But those are long, you know, those are pretty long processes. But and I'll give you an example of kind of a regulatory technology interface failure that I became aware of a few years ago, and it's in PHMSA, the Pipeline Hazardous Materials, is where you have in that particular case, PHMSA has some requirements. If you find an anomaly in your pipeline, you got to dig it up and replace it. Well, what's happened with detection technology over the last few years, you can find anomalies that are not a problem. So what that has done is discouraged pipeline operators from using the most advanced detection equipment. And because, you know, of that. So we want to, so it's this interface between technology and regulation. And I wonder if there's some, I don't think we're going to solve that problem in this study, but it may be an important thing for us to bring up in technology. There may be studies that people are aware out there that have that have really done a deep dive into this area, or maybe that's a follow-on effort, because how do you take this, which is very much the steps from what Maleva was taught, where you work with, whether it's the national labs or industry, or you develop this test criteria, but that's one part of it. But how do you then go through a regulatory process? And how do you do it in an area like this where if you're a company trying to, you don't want to do it 30 different state approval processes, ideally. And so that was kind of queuing this up, that is there a part that our committee should be looking at to kind of look in this area, and is there models out there for how to go through that process in an effective and efficient way. And before I do that, I'm just and I know Ilis has her hand up, but I just maybe, I know we have somebody from API, and you're welcome to add in if you wish to. But I think, Noel, we do have a plan to bring in the standards folks from API at a future meeting.
Yeah, at future meetings, yes.
Shall we go to Eilish?
Let's go to Eilish,
Eilish?
and then others can weigh in on this particular, the regulatory kind of technology interface issue.
Yeah, I mean, and if whoever's here from the API, I can't see the participants list. If they would like to jump in, that's fine too. But the last couple of years, not the last few years, but I've been involved with the API Cement Committee, Subcommittee 10, and we, so as a national lab with NETO, we have been part of their task groups or work groups, depending on what the focus is, and we present like a third party. So you have a lot of, several manufacturers involved in the work group. We provide the science and testing and work with that group, and then if there's whatever the findings are from whether we do robin testing or whatever is done, then that is then incorporated into the recommended practices. So that's how we usually kind of operate in that space and as a third party. And I think similarly with this committee, I think we can provide our recommendations. And I've been thinking about this even in another realm. I'm involved in the MERP program, IRA funded MERP program. And, I know as a national lab, we're really good at publishing scientific papers, but I wanted to take that a step further and, distill it down into, okay, here's what the important information is, and put it in a form that, a regulator or inspector or operator can utilize that information in a practical way. So I'm still kind of developing that process and how we can do that. So, but that's something that I have been thinking about. So I'm also open to input on that as well.
Thank you, Eilish. Any thoughts from the regulatory side of the audience?
This is Tom Grokash from Wyoming. Maybe I'll jump in with kind of an initial thought on, and Jim, you mentioned, how do we get to an approval point where, industry can, or the contractor can not have to speak to every single regulator when they want to use it every time. But, I think what we've heard so far is that it's an addition to the standard plugging procedure. It's not replacing a standard plugging procedure. It's to solve a specific issue that the standard procedure didn't solve. So in many cases, those are individual conversations, even if you know the material and know who you're using or what process you're going to do to solve that, you need to apply it to that specific scenario and make sure, you understand what are we trying to solve, what is the intent here, how are we going to show it successful, those kind of scenarios. So even though you may say, yeah, we'll let you use, whatever it is, we need to know. We need to understand those other specific scenarios. And I think to get there, it is also then conversation, we're happy to talk to anybody about a technology that might solve an issue that's present in this process. Whether it's replacement of the whole portion of the standard process, or if it's one of these that might be something to solve an issue in that initial process. But, we want to understand up front. Here's who's responsible for what. Here's, again, here's what we're trying to solve. Here's how we're going to solve it. Here's how we're going to show you that it was successful. And then, we can weigh those factors with our technical experts. And, we'll let you go forward. And if you can show that, then future conversations many times are quicker and easier. And so you get to a point where you're comfortable that they can do what the product claims and in what scenarios they can do it in. So, I think it's just an iterative process that you have to go through to get that knowledge and understanding about what it does. And if we can get lab data or something to help show that, or other operators.
Yeah, there's some thought around like what would help you establish those, because what you're establishing is a rapport with the technology. It just regardless of, you have a couple of different rapport with a provider, but you have rapport with the technology concept. Portland wasn't used always. We've already heard it was heavy mud. Now they're like, there was a report that had to be built. Like first guys were like, yeah, but I could go back in with that heavy mud. I could just circulate it out. I could do some things there. Now with that cement, what am I going to do? Am I going to have to drill? There was rapport with technology that might facilitate those discussions. Is it university findings, third party, unaffiliated testing that would provide some trusting? I see it like suggestion would be to build, how do I make a soil that would be good for innovate, that could help you guys develop or push forward things with a certain level of trust and comfort that would be better than where you are today.
Yeah, I think you kind of said it, probably starts research somewhere. We like the API standards, some of that reference a lot of times is in state regulations for API classes of cement or things that you automatically approve for use.
I've been
So
involved
those
in
kinda-
like API standards, but typically it's after
a long,
like the last big standard was section 13 in Article 10B-2. That was 12 years after we've already established that it was good. We're just like, how do we write standards around it, right? It took
Sure.
quite a-
Yeah, I think it's more is how do you facilitate the innovation cycle in a more, in a more timely way and broadly disseminate information.
Information that's trusted and validated.
yeah, I think we've got to be able to trust it. And whether it's in an orphan well or whether an operator is doing it, we've got to be responsible to the parties that, to the public health and safety, to, people who use.
You have a commitment to the taxpayers of your jurisdiction. That's
Sure, even if an operator's paying for it,
Yeah,
they still
exactly.
have an obligation also to make sure that when they put it in a well, that it's gonna do what it says it's gonna do, so we can rely on the protections that it's there to
And
provide.
facilitating that trust and learning, so you're not feeling like, well, I'm gonna take a leap of faith and I hope I made the right decision.
I
Right?
think that might be what it is, though. I agree with everything Tom said, but and API and all that stuff is great, but there's no substitute for real world application. Somebody has to take the leap, and then there's ways to disseminate that information. We've already heard, I'll just use BioSqueeze. There's, New York, Pennsylvania, Ohio, Texas are all using it. And all the states talk to each other. We already have mechanisms through organizations like IOGCC and other things where we share information, make
What's working.
contacts, and we talk to each other. We know what each other's using and if it's successful or not. And
What I've
it
seen
just
in
takes a
the
little
past done in certain projects, this was inside my own company, but we bought acreage and we built wells. And somebody come to us and said, hey, I got this, because we get that too. We're gonna put it in a well. And we trial it in our own wells that we do, right? We actually have those in East Texas. It's our little well farm. To trial things, but it could be something that's more standard. Could be facilitate this from That's fine.
So we have somebody from the audience, David Tabor has raised his hands. Could you please introduce yourself?
Yes, can you guys hear me?
Yes.
Yeah, David Tabor, Field Supervisor for the Department of Mineral Resources in North Dakota. I just wanted to kind of, I guess, piggyback on what Tom with Wyoming there is stating. North Dakota is open to newer technologies, and we've done a fair amount of similar things in I'm going to say remediation of wellbores with resin, similar things like that, but not for actual plugging procedures. I guess in North Dakota, how we handle a fair amount of this is the operator would need to come to us with what they're proposing in their new technology for plugging the wellbore. And we would basically be asking for documented proof and data that shows why that would be able to be used in our state and why it's a proven method in plugging. As Tom indicated, especially in the orphan well plugging standards, the requirements of those grants are put on the state to ensure those wells are properly plugged. And if it's a newer technology where we don't have a lot of data, I don't know how many states are going to be too, I guess, excited in the fact of trying something new in the orphan well process, especially on the grants, when it falls back on us in the state side to ensure that we met with the requirements and that is a long-term thing if we don't have actual long-term data to prove that or back us up on it when we approve it.
And in an orphan well scenario, it's like the states are the operator, right?
Yeah.
So that even moves that takes that other operator step out, and y'all are the ones making recommendations to yourself, right?
Yeah, essentially.
So David, before I go to you, there's somebody online, a comment from Amy Emmerich online. Thank you for the mention of API. Our standards program is ANSI credited. Critical standards for well closure include API recommended practices, well plugging and abandonment, API standard 65.2, isolating potential flow zones during well construction, and API RP 49. Recommended practice for the drilling and well servicing operations involving hydrogen sulfide, which applies to oil and gas well drilling, completion servicing, downhole maintenance, and plugging and abandonment procedures conducted with hydrogen sulfide present in fluids. Many other standards and recommended practices apply to the types of situations that are encountered during the closure and reclamation of orphan wells. We would be pleased to be a resource to the committee and thank you for your work on this issue. So Amy, I assume you are from API, is that right?
Yes.
Yes. All right, thank you very much. David.
No, great stuff. And I think that's where I want to go with this is, we have great organizations like API. We got the IOGC where everyone's talking. So there's organic mechanisms in play, but there's not a holistic central organization where you see maybe in some European countries or in Australia where, we have a center for decommissioning and abandonment or something like that, where maybe it brings all the right people in the fold. And, if that was to be a recommendation that comes out of this report, would that be something that'd be welcome where, it's not on the API to, carry the torch or the IOGC's, regulators, but at least an independent body that works, with public and private organizations to maybe steer, all right, we high grade, what are the top priority items? And now let's go find these innovators, maybe have an incubator, because right now it's kind of just all happened in isolation. If there was a more comprehensive or centralized group doing that, and then talking, and then that forum could reach out to our, neighbors across the globe and really, move things forward. So right now, that's kind of something I think we have discussed internally in this committee, but it'd be open to maybe some feedback externally.
I mean, I guess it depends on what the ultimate goal is. If it's a place that can kind of make recommendation, I guess to me, it would be a recommendation. I'm the one as the state regulator who's got to sit in front of my people in Wyoming and justify why we did what we did.
Yeah.
I can't just say, oh, well, this group out here that no one, that you all don't know about said this is the right product to use. So we used it and it failed. And now, we've got people with water wells impacted or other issues. I've got to be the one that explains to my governor, to my legislators, to the people of my state why we did something. So I'm not going to put my faith 100% in just what this other recommendation is on a new technology without someone coming and talking to us.
Yeah.
Proving to us that it works. looking at what it's done in other states, all those kind of things. So, we can have, I guess I'm saying the national standard isn't gonna work. A
No,
national.
I don't
place
think that
saying
would
this
be
is
the
what you
mission.
have to use.
Yeah, the mission.
It's still gonna be a local evaluation for that specific situation and that specific well with what we're trying to accomplish on that well, It would be great to have that organization be one, or have an organization out there, like API does or whatever, to be able to get these new technologies put out. Tested, evaluated, recommendations put there so that we can go to that and look at it and say, look, this is maybe a scenario they say this should work. Let's see, let's talk to someone else, see if they've used it. Yeah, see what it did for them. I think that would be very helpful
Yeah.
to, have a trusted place you could go, but it's still in the end, it is gonna be a conversation.
More local.
Like locally to decide what
You
is
know,
appropriate.
Yeah.
And I'm sorry, Adam, let me jump in, but I think of that, there's a group that does, that advances pipeline, safety technology.
So there's an example out there of
Yes,
what.
there may be groups like that that would provide that example
Yeah.
to do that.
What I envision is someone who just facilitates. You go to them and say, here's the issues, number one issue in Wyoming. How can you help me? Because we don't really want to test it on our orphan wells, but could you find an operator that is willing to partner with us to trial it, or, whatever it takes to get it to where it is an acceptable practice that we want, we consider on a specific, like I said, I think that's what we're hearing too. It's very case by case. The 95% plus cementing is still valid. But when you have these special, challenges, there's a need to look outside of cement or look, and that's what we're trying to do. But no one's ready to take that leap of faith without having some enough assurances behind it. So
Yeah, and Jeff kind of said aggregator before in relation to data, but in this case, it could almost be related to aggregating the technologies, figuring out how to get them tested, who can, so maybe.
So there used to be, and it still kind of exists, but it doesn't really exist, the Petroleum Technology Transfer Council, which played that exact role for a long time. And now they don't have any, I don't think they have very much or any money. Staff.
They exist in name only.
In name only, and so, there is a vessel that could be, revivified to do this exact function that we're talking about right now.
Would the state see that as a benefit to have something sort of a clearinghouse almost, or a place for them to go? I'm just curious.
It depends what's in the clearinghouse, right? So, I mean, if you're talking about an incubator, I heard that mentioned, there's actually going to be systematic testing of it in different, environments, and then the results of that testing made available for states to look at. I mean, I know when Paul was saying we allow for the new technology, they do meet with the vendor, the operator, and they talk about where else it's been used and what to expect and what might go wrong, and they have that discussion before we allow it. So if the incubator can serve that purpose, I think it would be helpful.
From Pennsylvania's standpoint, our plugging regulations in 25 PA Code Chapter 78 are very precise how to plug the well from start to finish, when cement should be used, at what interval, even like in terms of the definition of cement, what could be used. So I think, from a regulatory standpoint, it'd be difficult to bypass that without like what I was talking about before, that alternate method form.
And I think that's the idea of this interface of identifying, I gave the example in the federal government, part of the challenge is some of those, like the PHMSA, it is very you think it's hard to change your statute and rules. Federal government's like orders of magnitude longer to change, and that's part of the challenge, some of these innovation, you look at I use the example of methane detection technology, that technology in just a few years has really evolved, and we'd hope that other technology solutions would evolve too. And so how do you have mechanisms to ensure that we can take advantage of this technology advancements?
Cause that's how I see it, is like the private sector can do all they want, the vendor and the operator talking together, and then they go next step, talk to the regular, how do we navigate the framework? Wouldn't it be good to, instead of having it in a two-step, we're all in the same level? And if it's a non-story, it's a non-story. We don't waste time on maybe on certain technology or the other. So it's just, it's very high level. It's more just throwing the idea out there if that was something that would be, but I think from just a industry side would be up for it, because whether it's an orphan well or it's an oil and gas well that's still active, we can, leverage that.
I'll just add a quick comment there, David. So yeah, you're 100% right. So whenever we have some of these connections that are made with the operators, we find out at a later stage, and maybe doing like a 1 month or a couple of months debrief with them, that they are talking to the regulator. So that's where the touch point is, like once they see the technology viable to take all the consideration in terms of the parameters of the well, then they take the technology to the regulator. But I guess, yeah, that step is ahead of time. We might be able to refine some of these technologies.
Yeah.
And I think if you could do some vetting, a little bit of some of the studies, because I think Malayva mentioned it, the marketing can be really good on a product, but whether or not, when the state's looking at it, a lot of times you don't have much information. You may just have that, you may not have a lot of, you have to put a lot of time and effort into going out and finding real research on it. So the vetting of some of the research and the materials out there on those, that could be helpful as well.
Absolutely.
Adam Wygant, Michigan, I agree with everything said. I never see the case of where we're gonna advocate our decision-making on that for alternate materials or emerging technologies. I mean, our team vets those things deeply, but I don't think we're an obstruction. I mean, we're wide open to receiving new information and innovative things. So having third-party validation and all those things are very helpful. And then I would also say, Catherine kind of hit on it, where else has it been used? Because I mean, obviously we've got high trust levels with our sister states, and our program specialists are going to go to their program specialists and probably verify what's being said. But I don't think, even though that we have standards for like plugging material, maybe cement, almost everybody has the ability through some process to approve exceptions. And I don't think those are generally long, arduous processes. I mean, so
you don't feel like as a regulator that you're inhibited from trying new things? There are pathways to do it, and if somebody comes up with what seems like a reasonable idea based on data and experience, you can go ahead and try it.
And what I think you're hearing too is that we've already heard from multiple states that are using these products.
Right.
Maybe, again, most plug jobs are normal plug jobs. There's no failure, right? These are very small amount of cases where you need to use this stuff. You don't want to use these types of things in your standard plugging procedures. And states are using them, and we're disseminating information amongst ourselves. So it is happening. It's not like it's not happening.
And you have mechanisms to pass that information among the states and understand where it's been applied, and
we do, even in our state member organizations for regulators like IOGCC and Groundwater Protection Council. I mean, we've had technical sessions on polymer plugs, for instance. If somebody's got a good product, that's a good way to get in front of a bunch of regulators at a GWPC conference or a GWPC UIC conference. We have conferences that are more technical in nature that they're hungry for those things. Even workshops, if you got a really good thing, I mean, they'll stand you up and give you workshop time for a couple hours if you want on, the day before the conference officially opens.
all right, we've been going for about an hour and a half now. Maybe we could take a 10 or 15-minute break and then come back and kind of ask some more questions. That sound good? How about we're back at 20 of? Thank you.
So I was thinking, Adam, you think I don't know if this is a good analogy or not. I'm asking you because you're familiar with it. kind of, is there a role instead of like an organization, maybe it's, this would be something you'd have to find some federal funding to set it up.
Yeah. Oh, yeah, definitely. If you, I can just share him a screenshot of this.
Thank you all for still being here and coming back. Appreciate it. What we're gonna do is we're gonna ask for any more thoughts or comments or ideas about the topic we were covering before the break. Tom?
I just had one other thing maybe to mention on that. We should have mentioned it already, but through IOGCC, there is a standing committee there called Energy Research.
Energy Resources Research and Technology.
And so, I mean, and they partner pretty often with SPE through the year to offer, like, they do about 4 webinars a year, plus, you know, they have a 2-hour at least session at each of the IOGCC meetings, and that's also a very good spot for some of these new technologies to get out in front of states and,
Good.
you know, show technology, case studies and other things like that. So
The nice thing about that is it's offered to, you know, it's through SBE. Normally folks would pay for those webinars. But through this partnership, you know, they're offered to regulators for free. So these kind of products, I mean, it's just a good, easy access to the right people in the regulatory community.
Okay, can't see on my computer the name, so there's somebody,
Jim Bolander has.
there's one, but then Jim, go
No,
ahead, is that you?
I'll lower my hand.
No, he's lowering his hand. There's
You
so
have
many-
widely
Eilish.
online.
Yes, we do have a question online. A Whitley, I'm sorry, Amanda, if you want to unmute yourself and make a comment or ask a question, you can do so.
Please introduce yourself also, if you wouldn't mind, and your affiliation.
If you're speaking, we can't hear you quite yet. We still can't hear you. Perhaps we can turn to someone else. And Amanda, if you want to write your question in the Zoom chat, I can also message you to get your comment through. But yeah, why don't we keep moving for now?
Okay, any comments in the room? That are out there about?
Lisa, could I just add one other resource? AAPG has been also doing free webinars on various aspects on orphan wells, like from materials, technologies, reuse. So, and I believe they're also free.
Thank you, Mileva. Okay, at the risk of not beating this to death, I think we're gonna try and kind of think about a bit of a wrap up. And the way we thought about doing this was just going around the table and helping the committee understand what areas, what you haven't heard. In other words, what you'd like us to look at. And then also if you have any comments or key takeaways from this, that would be very helpful for us. Anything else we want to add to that list? No?
Nope, sounds good.
Okay, we're gonna start with New York.
So the question is based on what we were just discussing, what?
Well, kind of the last day and a half, you know, kind of what you've heard from the committee, what kinds of things that, you know, we as a committee should be looking at that you didn't hear us talk about that we may or may not be addressing so any advice you have for us too, of areas?
I don't have anything additional to what I said.
I guess parting thoughts, I thank you for having us. It's been fun to engage with you. Don't need to restate the things that have been said. Just hopefully what comes out of this. Still got to think about answering Adam's question about what we most want out of it. I don't want to be negative, you know, I like appreciative inquiry, but certainly what I'm hoping doesn't come out of this is leanings or recommendations that, you know, there should be national standards, national, you know, that state regulators that do this work. I mean, we train our folks extensively on cement calculations, how to monitor that, so any kind of national standard that's kind of pushing state regulators to have a minimum certification, continuing education, all those things. Certainly, you know, identify some recommendations or those kind of things in it, but I really think it should be left state to state. I mean, I kind of hinted that we tap into resources and we value training a lot in our organizations, but to have it dictated to us in any way or, you know, sort of a de facto standard, I think, is not what we need.
Adam just stole most of my thunder, but,
Can we clarify that?
Yeah, ask
So-
a clarifying question.
Just unequivocally, no, that's not the purpose of this study. We got that straight from the DOI disclaimers. The Orphan Well program does not see the consensus study as a step toward requiring a federal one-size-fits-all approach to well plugging or any other element of the work. So that is not, if that helps you sleep at night, that is not gonna be a finding or recommendation.
And we live by that, so.
Yeah, so-
You know.
Hopefully, maybe we should have said that yesterday.
Well, that's all right.
Yeah.
yeah, I guess just to build a little bit off of that, you know, I guess I would like, you know, the committee to keep in mind that, you know, all the oil and gas producing states have mature regulatory programs that have been developed by those people working within those specific states, the experts in their specific states, what's happening in their specific states over a very long period of time to create and constantly improve upon rules, regulations, and policies. And each state has crafted rules and policies and that fit the needs of that state. And I would just ask the committee to keep that in mind as you're, which it sounds like you are, as you're continuing to put together your report. So.
You don't have anything? Okay, Tom.
I think I'd just add, you know, I guess from what I see, and I think we've seen it in some of the previous engagement with states is, you know, there really are a lot of experts out in the states and their regulatory bodies, and I think you're hearing from a lot of the states kind of a similar message that, you know, they need the ability to be flexible and to be able to design their own programs and work within their own states. I think there are things we could help them with. I think the technology is one big one that, you know, we're, at least from my perspective, you know, we're pretty hesitant to adopt those until they're proven. So I think that's something that a report like this could really help clarify for states on how to get to that point. I think I might just stop there. I think that.
Yeah, can I add something to keep in mind? And my experience in the states have been very adaptable as conditions change. You look at the regulatory programs when shale came in, states were like many years ahead of, for instance, the Department of Interior. But maybe there's a conflict, and maybe not, but I'm just saying maybe there's a conflict with the, you know, federal regulatory system. Maybe it's EPA or something like that. And if there's something we could, you know, look at and identify specifically in the technology adoption technology space, that if there's anything there that we can highlight that could be helpful to the states. We may not know to highlight.
I would add to an extent, and in that regard, you know, one thing we haven't really heard from on the committee side, I think, is from the federal oil and gas programs. You know, we haven't heard from BLM on how they would do some of these things that we've been talking to states on, you know, and we share that regulatory, you know, especially in the western states, we share that regulatory authority, you know, with organizations like the BLM, and there can be differences between, and there are differences and conflict between their plugging requirements and our plugging requirements, and we can be imposing them and are imposing them on the same wells. You know, we regulate.
And that may be a useful thing, just not to choose sides, but to point out that these conflicts are not good.
Yeah, I mean, I think there's less conflict with EPA because they really don't have much authority in the well plugging world, which is where it should be a state issue. But you know, there are federal issues, conflicts if we call it that, or just.
That may be a good
discrepancies
thing
between
to figure out, and Tom, you're on the committee, maybe we'll work on some information gathering on that issue.
That'd be a good,
Having BLM more involved is a good point.
yeah, at least good, just, you know, maybe it is a good discussion.
Many of the states in the room, you know, they coexist. And I read both of the recs and I'm like, how do I please both of these parents?
Well, I mean, and it does get back to a scenario where, you know, the states have to somewhat be flexible. What we find is sometimes we're more flexible, so we have to be the ones that look at what, you know, an organization like the BLM is saying the operator has to do to plug a well, and we have to say, okay, if you do it that way, it will, or add this bit of a procedure or something onto it, then we'll be fine with that as well, and we'll say that it meets our rules. You know, because we're sometimes more flexible than they'll be. You know, they'll just go by what the exact word of the law is, and we'll say our regulations give us flexibility to meet a goal, not to just do a procedure.
It's a good point, because in your previous statements, like the nuance, the devil's in the details. BLM is a broader spec, and it's probably not gonna be applicable to every individual space from all the way to New Mexico to Wyoming and everywhere else in between.
Yeah, I think there's a scenario there to say, you know, a national standard isn't always appropriate everywhere. You gotta be flexible in it. But
So
anyway,
that,
discussion.
so we'll put this federal state interface on plugging.
Yeah.
On our agenda.
We use Adam from Michigan, you know, Tom speak well to this when you guys go offline, but, you know, obviously there's not. With oil and gas wells, you have that dynamic a lot in western states, a lot of the eastern states don't have with heavy BLM involvement. And with EPA, EPA has a disconnect, they don't have involvement with oil and gas wells, but they do with class 2 disposal and class 2 enhanced oil recovery wells, and they require plugging plans up front, which is interesting because you never know what the life of that well is gonna be or how it might be modified over time. States, you know, like we issue plugging instructions at the end of life, but before we got primacy, we did a good job of just dealing with that, working through EPA to please both parents, as was mentioned, but certainly primacy programs simplify that.
Yeah, and maybe clarify, just one clarifying point on that, EPA might have involvement if they're the ones implementing the UIC program. If the state doesn't have primacy, once that occurs, they'd have an air quality, I guess, interest, and that's about it.
This is Joe Gaboff from Pennsylvania. Appreciate everyone's insight. I would be interested in any research or developments in terms of some of the unique issues that Pennsylvania faces. I think some of the other states, and what I'm hearing, don't face the same attainable bottom issues we face. The shallow gas, the overpressured zone in the shallow formations. You know, like the case that I brought up the first day with pipe being rotted off 140 feet, you know, I'd be interested in whether it be specialty tools or different methods to, you know, maybe a squeeze method to get past that point or something like that. You know, I don't think that's really been researched that much. In terms of like the shallow gas zones that are infiltrating our plugs, you know, we do drill out a lot of plugs. There are a lot of plug failures. They're not documented as plug failures because when we do our inspection after operations, you know, we catch it, we have them drill out and it's remediated as such. But, you know, I'd like to see maybe some research or whether it be a technique or a cement blend, maybe a fast setting cement blend that, because it really is a race against time with those shallow formations. You know, usually that, depending on where you go, where they set that surface casing, 100 foot below it, which is where our regs say to start your chute plug. Now there's a gas zone there. And we usually don't find it till 30 days later. It's tends to be late in the cements or the slurries transition time. It loses its hydrostatic, and that's where you start getting your channels forming. So I think you know, that would be helpful to have a little bit more information on that, something that we could, or approach that we could use routinely, that's effective. Really like the discussion we had yesterday about the sort of the data collection. I think it'd be helpful to have like a reporting mechanism where we had different parameters, well age, well depth, formation, cement used. Then if we had, you know, big set of data, then you could do some modeling and, you know, predict where you'll have failures or, you know, where you'll be successful.
And a little follow-up, because you raised something, I actually thought of this yesterday, but I didn't want to I'm sidetracking today. I'm erring on the side of sidetracking the conversation. But you're interesting about cleaning out wells and technology for well, whether it's milling or other things. I was in some meetings earlier in the year and I've worked in a little bit in geothermal and oil and gas. And one of the interesting observations was that now that oil and gas companies are investing in geothermal, the drilling technology for geothermal for kind of the rock formations you have to drill for geothermal are different. And the advances in drilling technology supporting geothermal is like exponentially advancing because you have all this research. And because there's now, it occurred to me, is that a problem we have? Because most people don't have to clean out old wells and mill casing. And so the question is that a technology area that with additional investment, and I don't know, it's probably something for our job. I pose that rhetorically. There's something to us to talk about because we really haven't had drill, you know, service workover kind of well clean out technology on our list of technologies. And so I more raise that for our committee, but welcome any for the future discussion, but welcome any thoughts because we're just kind of using old technology on that.
Yeah, I mean, it's an interesting point. I mean, and it's anecdotal, but there's a milling operation that we're going through right now and, you know, we're making a foot a day, a couple inches a day with the existing technology. So I think it would be interesting to look at.
And that was kind of what my question was, is how many of those, right? But I think where it's going to become more prevalent is for these CCS area review and, you know, corrective action plans. There's a lot of those other wells lurking across the country in places that are looking at storage sites. So it's one thing to do it for an orphan well, and then we may be proactively doing it for corrective action. So there is a need for an advancement in techniques or technology or what have you for that specific application.
So maybe we'll put that on our list.
I think so.
So Eilish, before we get to you, there was a comment from the audience, Corey DiPaolo. Sorry if I butchered your name.
No, you did it well. Thank you. Hi, this is Corey DiPaolo. I'm the Western Region Orphan Well Program Supervisor for this auto. And just a couple comments. I agree, including the BLM and maybe these conversations would be great. Just we've had some good success recently with dealing with both the state office in Denver and really focusing on our relationships with the field offices. And we have seen some pretty good cooperative progress with the BLM and some well plugging. But one of the things and challenges that we see is the how long it takes BLM to actually orphan their wells. And that is a pretty long process. That can be anywhere from 4 to 5 years, depending on the operator and leaseholders. So definitely a good conversational point there. And then the gentleman from Pennsylvania, we also have casing that is from the 40s and 50s that we ran into that is typically akin to open hole or lacks mechanical integrity. And one of the things that we have seen success with is landing, say, liner in the center and then running basically a capillary string or tubing on the outside and cementing outside of the casing and allowing that to set and giving a migratory path through the center of the pipe for free methane. And then after that, we can stack cement further up that pipe and run a CBL to ensure bond, and also then use mechanical aids to plug those said wells that are shallow gas. So just some food for thought there.
Thank you, Corey. Eilish?
Yeah, it was just a comment for Joe. I work with some of your other colleagues, and many years ago, I worked with Seth Polepko, but we've been doing some work on like determining if cements are going to have issues with gas migration, and we've been focusing on shallow gas migration. So I'm happy to tie you in if you're interested in that. And we, are welcome input from the states, because we don't really have necessarily practical knowledge of what questions you all have, and we're more than happy to work on different research projects and design experiments and testing to look at different problems. But I'm happy to tie you into that group if you're interested.
Okay, great, thank you.
We're also looking at type 1L cements. I'm not sure if you are aware of that initiative.
We are.
What was that? I'm sorry.
I said we are.
You are.
Yeah. Yeah. I mean, that's with Joel Keller, I think, is leading that with Don Hedberg and Doug Catalano or Lino. They're part of that group.
Right, yeah.
So on the type 1L cements.
All right, any comments from the committee members, either online or in the room? Any further comments?
Just
Or
appreciate everybody's time. It's very valuable.
I guess my comment is, can we get back to you if we have to clarify, we want to clarify some of this, because I think, the dialogue will go away and think about it for a while and then go, why didn't we ask that? Yeah. Any other thoughts from the committee?
I think
However,
this would be a really good opportunity for us to at least attempt to put some of these in terms of technologies and materials. We can at least provide a good collection of information in one place, and this consensus study publication maybe can start as a seed to establish an organization that can be a go-to for all of the states with their specific issues. I do really appreciate that you reminded us this should not be one size fits all, and we're all committed to that. Thank you all.
Let's say we did yesterday talk about a number of things that I think there's some follow-up, and we'll kind of figure that out. And one of which on this failure thing, and is there data, and we'll kind of sort around how to do that. Maybe we'll rather than go out with like asking 30 states for something, maybe we'll do a little test run with 1 or 2 states, say, hey, does this data work to look at this and kind of see where we are, and then we'll be back in touch, I know, on that.
and I think we're interested in case studies, so part of what we want to put in there is of putting case studies in there, so we may be back to people, the different states, to try and get a better understanding. So I think those are really illustrative in terms of.
That was my exact thought after Eilish and Joe had talked about linking some of these things up. Local drillers with a lot of experience and regulators that have been around, they know how to get past obstructions, but they kind of know what they know. I mean, they've got a lot of tools for doing that and methods, but to the extent case studies could be kind of good about just where you had a plug failure or difficulty in drilling, sealing off these zones to get effective plugs. There could be value in linking up. Just, it might be basic, or it might have been something innovative, but some success stories in that. Some of your older drillers might know that. Some of your more advanced drillers might know that, but if you're gonna do a report, it kind of institutionalizes some of that.
Well, and you made a really, you said success stories, because I think some of our case studies are to illustrate problems, and I think we should make sure we balance that with success as well. But I think that both. And I think one of our approach is that the case studies help illustrate things that and be able to convey information. And especially if we can't do some of the deep analytical work we would like to do.
Yeah, we may have to try and illustrate points with case studies as opposed to actual data, because sometimes the data is not there, so. Not available. All right. I think we're grinding down here. So any closing thoughts?
Yes, very quick. So yeah, I would like to again, thank you all for having, Darts and Partners involvement. And again, it's encouraging to see over the last couple of days to how the momentum has been going around for R&D technologies for non-traditional cement plugs, monitoring plugs. And as Jeff and Joe they mentioned, we're happy to explore and aggregate some of this data on some of the technology trials from different operators, whether mostly, I believe they shared the success stories with us, so we can compile these 4 different cases within North America and how some of these technologies have been beneficially trialed and viable in these areas. And then maybe if, as we were having discussion with Joe mentioned, there are some records already being there with the state regulators as well that could be collaborated as part of this report. So we are more than happy to aggregate that.
Thank you very much, and thanks for your presentation. I thought it helped drive the conversation, so I appreciate it.
Appreciate it.
Eilish.
Yeah, just a closing thought. I think we had discussed this in one of our closed sessions, maybe one of our initial ones, but we even, it's like the API recommended practice on well plugging, I think, states it really well that, the states have the ultimate authority, and, they're just providing, recommendations. And, we've had these discussions as well. Like, we're not going to be, pushing any one technology. We're not going to be, or we can't, advocate it for any one type of technology or company. But, we see this as, and I think, it's stated well by the DOI, but just to reiterate, this is meant to, be a tool for states and to help them. So, anything that we can include or look at that, maybe we're not looking into and it would be helpful, we want to be able to provide relevant recommendations from this study.
Thank you, Eilish. Any other final comments? I'd just like, on the behalf of the committee, I'd like to thank the states for coming and talking to us and being so open with us. It really is incredibly helpful. And we may, if you think of something, you get on an airplane and think of something, just, drop us a note. I think all the emails are out there, so we can follow up with you. We may be back at you to, can you have another conversation with us? So, but we really appreciate all your help with this. So any final thoughts from the committee?
Seconded.
All right, this is officially closed. The session is officially closed.